Howdy, y'all, and I'm hoping everything's good for you guys today. Today, what we did in class was we talked about the idea of rational exponents and how they are related to radicals. And today, the first video that I want you guys to watch is dealing with simplifying square roots. And remember, when we defined roots a second ago, we defined roots as the root of a number x is the number which is multiplied by itself a number of times equals x. So when we talked about the idea of taking the fifth root of 1024, we said it was 4. And the reason why that's the case is because if I were to multiply 4 times itself 5 times, I am getting 1024. So when I'm saying that the fifth root of 1024 is, I'm asking myself, what number can I multiply by itself 5 times that gets me this number, which is 1024. So if I were to look at um, something like this, and I want to simplify these, I am asking myself, how many what number can I multiply by itself that gets me 144? Well, that's easy. I know that's 12. But what does that mean? Well, if I were to take the square root of 12 times, I can break up the square root of 144 and say, hey, it's the same thing as me saying the square root of 12 times 12. The reason why I'm saying that is I know that 12 times 12 gets me 144. Well, I have the two things that I can multiply together that get me 144, so that means that the square root of that number is 12. Now, if I were to look at the square root of 256, I am asking myself, what can I multiply by itself that gets me 256? So if I were to say, hey, the square root of this if I were to say 16 times 16 gets me 256, or I could just put in my calculator the square root of 256, I would say that it's 16. So what happens is when I have two of the same thing, underneath a radical, I can take one out. So because I had two 16s underneath the radical sign, I could take two or one of them out. So let's just look at an example. Let's look at the square root of 54. Now, there's no perfect, like if I were to take the square root of 54, I would get that to be like 7.34. So that's not it's an irrational number. So I want to simplify this more. So what does that mean? I'm going to take 54 and do a factor tree and say, hey, what can I multiply here that gets me 54? So I'm looking at it and saying, hey, 54 is divisible by 9 6 times. Well, those aren't the same number, so I'm going to keep on breaking it down. And I know that 9 breaks down to be 3 times 3, and 6 breaks down to be 3 times 2. So I have this all underneath the square root sign. So I want to simplify this. Now remember, what we did a second ago is because I had two 16s underneath the radical sign, that meant I could take one of them out, which in this case I have two 3's underneath the radical sign. So because I have two 3's, that means I can take one of them out. And I could say, hey, 3 square root of 6 is the same thing as the square root of 54. Okay? And if I were to multiply 3 times the square root of 6, I would get the same decimal, 3 or 7.34. Now, let's look at 112. I want to simplify the square root of 112. Well, if I take the square root of 112, it's like 10.58. So I'm going to break down 112. And I'm going to say, hey, it's 2 times 56. Um, this is 2 times 28. This is 2 times 14. This is 2 times 7. So when I look underneath my radical sign, I have 2 times 2 times 2 times 2 times 7. Okay? So for every pair of something, because I'm taking the square root, for every 2 of something, I can take 1 out. So because I have one pair of 2's, I can take 1 out. Because I have another pair of 2's, I can take another 1 out. So I end up with 4 square root of 7. So for every 2 of something, I can take 1 term out. What I'm going to ask you guys to do is to try the next 2, and we will talk about them tomorrow. Have a great day.